In this presentation of the pixel processing software, we're going to take a look at a feature called camera calibration. One of the issues with inexpensive webcams that work with OpenCV and as well as a lot of cell cameras is that there can be a significant lens distortion. Now, let me show you what I mean by that. Here's an example of a common chessboard or checkerboard pattern that's used for camera calibration. And if we draw a line from one of the corners across to another one, the line that's drawn is actually straight, but the lines of the chessboard squares don't line up very well with that line. The same thing here with the line I've drawn at the bottom. And this is the example of the lens distortion that's common with inexpensive cameras. To account for this, we can actually compute a camera calibration matrix and distortion coefficients that will allow us to warp or undistort this image so that the edges of the chessboard squares are along the line. Let's see how we can do this. In the pixel processing software, there's a feature for camera capture, and what this allows you to do is to capture an image or a sequence of images, and you can grab them and save them in a folder and perform a calibration for a camera. I've only tested this camera capture with a couple of different cameras that I have access to, and I've placed those specific cameras in the FAQ section of the pixelprocessing.com website. If you have familiarity or experience with other cameras, please feel free to contact me and I'll add them to the list. In order to do a camera calibration, we need a series of different views of either a chessboard pattern or a pattern of circles. Here I'll demonstrate with the checkerboard or chessboard pattern. The number of views is not an exact number. It's maybe as much of an art as it is a science, but I've found that around 12 to 16 views seem to work well, and here's what I do. So if you have more than one camera plugged in, you may be able to select between them, and generally the highest resolution comes up first, and that's probably what you want to use, and we'll use a live capture type, and we'll start, and the destination for the live capture will be in this third image here on the right. And so here you see a live view. I can wave my hand in front. You can see a live view of the calibration board. And what I've done is I've just printed out this chessboard calibration pattern that you can find online, and I've taped it down to a clipboard so that the calibration view is nice and flat. That's important that that calibration image be fairly flat on a plane. So now, how do we get the different views that we need? One of the things that we can do is I'll stop the live view so that I can clear out this series that I've captured earlier and maybe bump up the number of maximum that I'm allowed to capture, and then we'll start again. So what I typically do to get the 12 or 16 different views is I take the calibration board and I rotate it 45 degrees, and that'll give me 8 different views. So I have it lined up this way, and then I'll just rotate it roughly 45 degrees and make sure that all the squares within the chessboard pattern are visible in the image. We'll rotate it another 45 degrees, and at each rotation I will add that image to the sequence. And I'll continue this for 8 rotations of about 45 degrees and making sure that all the checkerboard squares are visible. And the next thing that I'll do is I'll take a book or something and prop up the clipboard so that it is no longer in the same plane as it was before. So all I've done is taken a book and put it underneath one of the sides of the clipboard so that it's propped up at one end, and now the plane of the calibration pattern is not lying flat like it was before. And I'll do the same thing, grab another 4 views at 90 degrees each, or maybe 8 views at 45 degree changes each. When you do that and you have all those views that you like, you can click on this link and it'll actually open up the temporary folder that the pixel processing software uses, and you can see the sequence of images that you've captured. Copy all those, and then what I do is copy all the sequence images that I'm interested in and go to another folder that I've labeled for this particular webcam. It comes up as HD 720 webcam, and copy all those images in there. So here are the images that I was able to get from the temporary folder and then copy them into another folder. So you can see I've got a series of images rotated roughly 45 degrees each. And then we actually have some that are maybe hard to tell, but here you can tell it's propped up a little bit so that it's in a slightly different plane as before. Once we have the calibration image sequence that we're interested in, we can turn to the camera calibration feature of the software. And here we can load up the calibration views, select them all, and add them. And then we have some options here for the board type and some calibration options. So another common calibration pattern is a grid of circles, but here we're using the chessboard pattern, and the pattern size for the circles grid is just the number of calibration circles, the number of circles, the width and height of the pattern of the circles. For the chessboard, it's the number of interior corners. So for this particular chessboard pattern here, it's the number of interior corners. So this one here is the first interior corner. These ones on the outside don't count. So if we count these up horizontally, I get 16, and if we count them up vertically, I get just 9 interior corners. So I have to change this pattern size to 16 by 9. Okay. So once I have the other option, once I have all the images loaded, I've got the board type selected, I've got the pattern size, I also have this option of using object releasing. So if you go to the OpenCV camera calibration documentation, you can read about this technique, this optional technique referred to as object releasing. And I have it checked here by default because it seems to work better if you use it. So once you have your parameters set up and you have your images loaded, you can actually now do the calibration. So you can click calibrate, And this takes a few minutes, so I'm actually going to pause the recording here and we'll come back and see the results in a minute. Okay, so the calibration finished and the message window popped up and it told us that it found 144 points in 17 images. So that means that it found all the calibration corners in all 17 images that we have, and that's a good thing. In some cases, if some of the corners are slightly off the screen or for whatever reason, it may not be able to find all the calibration points in all the images. In that case, the particular image will be discarded or not used to contribute toward the calibration. You may want to retake that image, see if you can do better. The other thing that's output in the camera matrix, output in the message window is the camera matrix. And this is the information needed to, along with these distortion coefficients that are needed to warp or undistort an image. And we also get a calibration error, and of course the smaller the error is, the better the results are. We can save this camera matrix and distortion coefficients in a JSON file just by hitting the save button and giving a name, calibration data. So that information is saved, and later on, if you want to test this with other images, you could actually load up that same calibration file and do this next step, which is we're going to look at the markup for one of these images before and after the calibration. So if I take one of our images, and it seems to work better with one of these horizontal images, and choose the show markup option, what happens is we get a before and after view of the particular calibration image. If we view this in our external viewer and zoom in, we can see that, as we saw before, the line doesn't match up as well with the edges of the chessboard squares, both at the top and on the bottom. Even though the line starts and stops at the corners, it doesn't align with the edges of the chessboard or checkerboard pattern. And again, this is due to the lens distortion that's common in inexpensive cameras. The after view, which is on the right side, you can see that the lines do match up fairly well with the edges of the chessboard squares. So the markup image shows us the before and after when the camera calibration is applied to undistort the image so that we get lines being actual lines in the image. They're not warped due to lens distortion. So this is how to use the camera capture and camera calibration features of pixel processing software. For more computer vision demos, or if you want to try the software out for yourself, visit pixelprocessing.com and feel free to leave comments here, and also feel free to contact me. Thank you for watching.